Okay, so check the table, please, the state table. Why is it called the state table? Because I have two flip-flops, and two flip-flops will give me four states. The four states are 0, 0, 0, 1. So this is a state. This is a second state, third, and fourth. So you have 0, 0, 0, 1, 1, 0, and 1, 1. Each one of these is called a state. Okay? If I have two flip-flops, then I will have two states. Okay? So how do I create, what is this? This is input X, and this is A and B. Now here is A plus and B plus, and that's the output Y. Okay? So who can help me, please, to fill in this data for the Y? Sharbil, can you try? How do I fill the data?
We take the expression of y, which is yt x bar t, b plus a. And then
This is simpler to read, right? Okay,
yes.
so what's the first thing you should do? Since you have an and, you do this or this, right?
So we make the multiplication first before the plus.
Exactly. So we look at the x bar. Yes, when do you always have zeros in the case of x bar? When x is?
0. No. When x is 1.
When x is 1, you have a 0, right? Okay, so this is going to be a 0. This is a 0, a 0, and a 0, right?
True.
Agree? Now, when will you have a 1 in the A or B?
When
One of them is 1, right?
okay.
When one of them is 1. So here, they are both zeros. So this is a 0. Here you have one of them to be a 1. So this will give you a 1. Here, one of them is 1. It will give you a 1. And here.
And both are 1.
Okay? Is it clear? How did we fill the table? The same goes for B plus. B plus is A bar X. Yes, Carmen, how did we fill it? For the B, please.
Okay, so
when do you have a 1?
B plus.
Yes, in the B plus. When do you have a 1?
When we have A bar 0 x1.
So this is a 0. This is a 1. So you have a 1. This is a 0. This is a 1. You have a 1. Right? And the rest will be zeros. Right?
That's it. Long zeros.
Okay.
Yes.
Yes, we have now x into a plus b. Yes, George, can you try?
Yes. Hello. دكتور سمعتيني؟
Yes, I can hear you.
اوكي آية واحدة بس.
This, the a plus. This.
اوكي. A plus هي AX plus BX. No. أو X factor A plus B.
Yes, this is easier to calculate. You look at the x alone. When x is 0, what will happen? It will be a 0.
Zero.
So when x is 0, so let me erase the old ones. When x is 0, this is going to be 0.
Yes.
Yes, now what?
إذا X 1 بدنا نشوف يا A يا B يكونوا 1 أو 2.
Yes, one of them is 1. So this is all these 0, so it's going to be 0. Here you have a 1, so it's a 1.
Okay.
Clear? So
Yes.
this is called the state table. Okay, we did this last time and I repeated it today, so I make sure you got it. Another way, which is called an alternate state table, it's exactly the same, but this is a two-dimensional. So we are working on the two options at the same time. So notice please what you do. You list the states, so you have 4 states because you have 2 flip-flops, and it's going to be, if x is equal to 0, you fill it. If x is equal to 1, you fill it. If x is equal to 0, what's your y? If x is equal to 1, what is your y? So you'll have 4 cases, okay? So let me start with the first one, please. Here you have x into a plus b, okay? So how do I fill if x is equal to 0? What is going to happen if I replace this x by 0? All of them will be 0, you agree?
All the answers.
Exactly, so I fill them all with 0. How about when you have in B now, here? Fill all of this with the 0. What are you going to get with the B? Also all zeros. Okay, how about the second? When you fill x is equal to 1, okay, and now you have to check A or B if it's going to be 0. So here you have a 1, so you fill it with a 1. Here you have a 1. Here both 1s, so it's going to be this answer. You got the idea? So it is exactly the same, but this is a different way of filling, where you fill once for x0, once for x1, and then once for y equals 0, y equal to 1. Okay? We will start now with the state diagram. In the state diagram, every state is represented as a circle, and you write in the state the name of the state. So let's say state 0, 0, and put it in a circle. And you will have the next state, again, it's another circle, 0, 1. And the line that you see, it's called an arc. We call it a directed arc. And on the arc, you write the input that you have. So let's say your input is 0, it will go to this state. And on each state, you will have to write what is the output that you get. So it's going to be, let's say, 0/1, where 0 is the input and 1 is the output. Okay? Let me show you an example. So on the circle, you will have to put the state and the output. Okay? So if it is more, look what you do. If it is more, you write the name of the state, dash, and here you put the output. This is if it is more. If it is Mealy, I have 2 designs. If it is Mealy, I cannot put the output in the same state. So I will have this state, let's say, as 0, and this state as 1, and on it, I put the input / the output. Okay, so this is the difference between drawing the state diagram in a Moore design or in a Mealy design. Okay, let's do an example. If you are following the figure, okay, how can you read this table, please? I am, look, I will write it down so I make it clearer. I am in state 0, 0. I got a 0. It remained in state 0, 0, and the output is 0. So this is A, B, X, A plus, B plus, Y. Okay? Now you tell me, please, I am in state 0, 0, and I got a 1. Elisa, can you try? I am in state 0, 0, and I got a 1. What happens? So I am here, and I got a 1. Where did it go? Follow the arc.
0, 1.
Very good. And what's the output?
0, 0, 1. Oh,
Yes, you are right.
okay.
The output is 0, right?
0, yes.
So this is a 0, this is the 1, and this is the 0, okay? Okay, we continue. Hiba, your
Okay.
turn. I am now here in this state. Okay, Hiba? and I
Yes,
got a
doctor.
0. Where does it go? Sorry.
Yes, can you repeat?
I am here, and I got a
Okay.
0. What happens?
Stay 0.
Follow the arc.
Okay. Doctor, I didn't understand.
Okay. So you are in state 0, 1. So you are here, and you got a 0.
Yes.
It takes you to the next state, which is this. So it takes you to 0, 0. And what is the output? 1.
1.
Okay,
Yes.
so I did this. Now your turn. I am in state 0, 1, and I got a 1. What happens? So I am in 0, 1, and I got a 1. Follow the arc.
1 كمان.
Where did you go? Which state?
عم تحكي عن اللي فوق مش اللي تحت.
I am looking at this circle. Okay, I am
Yes.
in 0, 1. I got a 1. It took me to 1, 1.
Yes.
And what's the output?
0. Okay.
Yes. Okay?
Okay. Okay.
I
ماشي.
still want you to do 1 to make sure you understood. I am in state
Okay.
1, 0.
Okay.
I got
1
a
0 اللي
0.
حد ال 1 1.
Here.
Yes.
I got a
I
1.
get is. Okay.
Sorry, excuse me. I got a 0. You are right.
Okay. So the output is 1.
Yes, the output is 1. But where does it take me? Follow the arc.
Mm,
Follow the
to
arc.
the 0. Yes, to the 0.
0, 0.
Yes.
Yes. Okay? This is called the state diagram. Is it clear?
Yes, it is clear.
الدايجرام انت بتعطيني دكتور دايما ولا نحن نرسمه؟
This, you will have to draw a state diagram.
اوكي.
And from the state diagram, you can find the state table. Okay, from the state table, you can find the equation. You can draw the logic diagram. I will give you one of them. You will have to do the other 3. Okay?
اوكي.
Did you get which other 3 you want to do? Or you want me to repeat? This
عندنا
is the
الدايجرام وعندنا التيبل والايكويشن.
with logic diagram. Okay, I have 4.
كله diagram.
So I have
Yes,
the diagram, I have the state table, I have the equations, and I have the logic diagram. I have 4. The logic
Yes.
diagram or state diagram. This is called the state diagram. And you have the state table. Okay?
اوكي.
Doctor,
Yes.
what's the difference between Moore and Mealy's design?
In the Moore, you put the output inside the state, not outside on the arc. Okay? لاحظ هون. See?
Okay.
See here you put inside, here you put outside. Okay?
Okay. هيدي الشخطة يعني بقلب السيركل. Okay.
Yes, this one here, this is the output. So here, if you go to the next state, it's going to be you go to S1 and output, let's say 1. So this is going to be your X here. So what's the difference? Here my Y is outside, here my Y is inside.
Yes. طب بس هيدا الديفرنس بتكون يعني بليفل الدياجرامز stated diagrams أم في
Yes,
كمان
but
شيء
why?
تاني؟
But why? It's very important to understand why it is like this. Because in Moore, the change only depends on the input only. Whereas in Mealy, okay, every state has a different output. So here, a 0 is always 1. Whatever is the input, it's always 1. Here, a 0 might have different outputs depending on the X. You got the idea?
Not very clear, to be honest.
Okay, we repeat. Moore, if I go to the very beginning of it, okay, to the very beginning, when we explain Moore, we were talking about, bear with me 1 second. Here, we were talking about that Moore depends only on the state. whereas Mealy depends on the input and the state. See the difference? So here, the output of Mealy, okay, will differ according to the input and the state, whereas in Moore, it only depends on the state. So every state that you have, let's say state as 0, the output is always going to be 0. It doesn't matter what the input is. It's not a function of the input, notice?
Yes.
Whereas in Mealy, it is function of the input and state. So it matters to me what is the input, because if I input is 0, it might take me to S1. If the input is 1, it might take me to S2. See?
Yes.
Okay, and here I have an input 0, here it might different 1. So I have different outputs, whereas here in the Moore, I have only one output no matter what is the input. The state always gives me output 0 or always give me output 1. It doesn't matter what the input is.
اوكي نحن لهلا شايفين بس المور انه بالهول شفناهم.
بالرسمة we only checked Mealy till now because the output is outside.
ايه قصدي ميلي.
We did not check the Mealy yet. Okay. Okay, I want to draw this with you. This. I want to draw the state diagram of this with you. Okay, can you try? Who wants to start? Eli, Saba, would you like to start? How many states do I have? No? Who wants to try? Yes.
I can.
Yeah, let's try, please.
We have عنا لأنه 2 bits بيكون عنا 4 states. إنه عنا 2 states.
So these are my 4 states. And what are they called? 0, 0. We go clockwise. Okay. Yes.
على
We are in, listen to my sentence and follow it. We are in 0, 0. We got a 0. It takes us to 0, 0, output 0. I am in state 0, 0. I got a 0. It takes me to 0, 0, output 0. Okay?
We're gonna stay in the same circle. It's like out and then in. True.
Okay? Now do the second one, please. I am in 0, 0. I got a 1. It takes me
1
to
0 1 والاوتبوت 0.
0
Is it clear? Okay? Every state you must give it once a 0 and once a 1. Look. Now I am in state 0, 1. Yes, please. Give it a 0.
it remains 1.
I am in 0, 1. I got a 0. It takes me back to 0, 0. And 0 dash 1. Now I am in 0, 1.
input 1 تاخذنا على الستيت 1 1 والاوتبوت 0.
Okay? Now I am in 0, 1. And I got a 1. It takes me, yes. Okay, now I move to these two. I am in 1, 0, and I got a 0. So this is 1, 0. It takes me to 1, 0, to 0, 0. Okay, and this is 0 dash 1. I am in 1, 0. I got a 1. It remains in the same. So 1, where is it? 1 dash 0. Now I am in 1, 1. I got a 0. It takes me to 0, 0. So this is 0 dash 1. And I am in 1, 1. I got a 1. It takes me to 1, 0. 1 dash 0. Okay, so this is the state diagram from the state table. Clear? Now, how do we find equivalent state definition? Two states are equivalent if their response for each possible input sequence is an identical output sequence. So it gives the same state. So look now, please. I am in state as 0. And the output is 0. First, is this a Mealy or a Moore? What do you think? Is this a Mealy or a Moore? This is a Moore because the output is inside, right? Okay.
The more
And if you look at it, a 0 will take me to S1, and S1 will take me to, if I got a 1, okay, it will take me to, check here please. So S0 will go to S1, and S1 will go to S0, okay? Notice here. Let me change this to a pointer. Here, I am in S0. I got a 0, it remains in S0. I got a 1, it goes to S1. Right? I am in S1. I got a 0, it takes me to S0. So S0 takes me to S0, and S1 takes me to S0, and I get a 0. So we say that S1 and S0 are equivalent. Okay? So look at this, please. I have now S0, S1, S2. If you notice their output, let's say S1 and S2. So I am in S1, I got a 1, it takes me to S2. I am in S2, I got a 1, it also takes me to S2. So S1 and S2 are equivalent, I eliminate S2. So what tells me that two sets or two states are equivalent? First of all, the same input takes me to the next state, and it gives me the same output. Okay? So here, check S3. I am in S3, it takes me to S2, and S2 also takes me to S2. Notice? So if I get a 1, it takes me to S2, output 0. And S2, if I get a 1, it also takes me to S2 and output is 0. This means that S2 and S3 are equivalent. So I eliminate S3. Okay? But I have to repeat, it must be the same input, the same output, and it takes me to the same state. Okay, so I say they are equivalent. So here, S2 and S1 are equivalent, and I get this figure. This is called a state diagram, and I eliminated all the equivalent states. Okay? Now, what is the difference between Moore and Mealy models? Moore is named after E.F. Moore, and Mealy, of course, is after George Mealy. And outputs are a function of states only. So this is why in Mealy, I write the state and I write the output here inside the state, okay, whether it is 1 or 0, let's say. And this is the Moore model. And on the arc, I only write the input, okay? Whereas in Mealy, I will have on the output line, on the arc, input/output, and in the state, I will only have the name of the state, not the input also. Is the difference between the two clear? Now, Mealy model, if you have,
دكتور
yes, yes,
قبله مش احنا قلنا انه طلعنا السوق ليش جدا
are you talking about equivalent?
ايه
So طلع please على S2. If you got a 1 0, 1 0, it takes you to S2, you agree? And here, if you get a 1 0, it also takes you to S2. So S1 took you to S2, and S2 took you also to S2. So they are equivalent. Same input, same output, and same state. Okay, so the input is 1, output is 0, next state is S2. So كل هول they took you to the same state, so you say they are equivalent. Same input, same output, same next state. They must be all the same. So you get the you have equivalent states. Okay. So we go back to Moore and Mealy. So here you have the state and the function is output is inside, whereas in the Mealy you have the input and output on the arc. So they are displayed on the arc. Okay. Okay, so here Mealy model state diagram. You have the input and the states to the output. Okay. Notice here, please, that you have state 0, state 1. And you got a 0 on the state 0, you remain in the same state and output is 0. Okay, so this is a Mealy model. In the Moore model, you will always have more state, one more state. Okay, these two are equivalent, but one is represented in Mealy design and one is represented in Moore design model. And notice, please, that the input is outside and the output is inside the state. Okay? Clear the difference between the
بس
two?
هذا الفرق بيناتهم.
Yes, الفرق بيناتهم إنه هون بهيدي in the Moore every state, so let's say state 0, the output is always 0 no matter what is the input. The output of S1 is always 0. The output of S2 is always 1. You see? That's in the Moore. How about in the Mealy?
Yes.
In the Mealy, state as 0 is this. Sometimes it has an output 0, sometimes it has an output 1. You notice? It depends on what is the input. See?
Yes.
This is the difference. So
Thank you, doctor.
the output is function of the input and the state in the Mealy. Whereas in the Moore, it is only a function of the state. So only the state will have always the same output no matter what is the input. This is the idea. Okay?
Yes.
I want you to look now to the difference in the state table. Okay? Notice, please. State as 0 always have an output 0 no matter what is the input. Doesn't change it. S1 has output 0, S2 has output 1 always. Okay, whereas in the Mealy model, the output will change according to what is the input. So if input is 0, you get 0, 0. If input is 1, you got 0, 1. So see how the output is changing? Okay, so this is another way that you can tell if your design is a Mealy or a Moore based on the output. So you look at the output. Is it not affected by the input? You say it's Moore. Is it affected by the input? You say it's Mealy. So you tell me, please, is this Mealy or Moore? I know it is written, but you tell me, Ray, is this Mealy or Moore? I know it's Moore, but tell me why.
لأنه الأوتبوت عم ضله زيرو، مش عم يصير 1 وحتى مش عم يتأثر بالإنبوت.
So the output of state 0, 0 is 0 always. The output of 0, 1 is 0 always.
Yes.
See? So the output is the same no matter what
Output
is.
of 1 0 هو 1 مش أصلا 1.
لا إيه بس للstate as 0 it is always 0. للstate as 1 it's always 0.
Okay.
للstate as 2 it's always 1. State as 3 it's always 0. It is not
حسب الستيت.
changing. كل state عندها output. Notice it is written inside. See? 0,
Okay.
0. This is S2 and this is S3. You see?
Yes.
So it is not affected by the input. Okay?
Yes, okay.
So now, given the state table, you want to find the equation. Okay? Given the state table, you want to find the Boolean expression. How do you do it? You have A, B, okay, and the input. So A, B, and input X. And you fill them in the K-map, and you find the equation of the adjusted ones. Okay, and it's going to be I, A. where I is the input. Do you see it? So this is how you find the equation of B plus. Then you will have to find the equation of A plus, and then you will have to find the equation of O. Of course, the equation of O is easy to recognize because it is A, B bar. Okay? So this is how you find the equation of A plus, B plus, and O. Okay? So notice please now they are filling the equation of the A plus. If you look at it, you can take these two adjacent, and then you take these two adjacent, and you find the equation. Okay? Now, if we want to draw it, so A is I into A plus B, and B is A bar I, and O is A B bar. So this is how you draw the logic diagram. Can someone tell me, by looking at this, how can I know that this is Moore? By looking at the equation of the output, how do I know it is Moore, not Mealy?
There is not an input inside the expression.
Perfect answer, perfect answer. You do not have I in the expression, so O is not a function of I. So this tells me it is Moore. Okay, in the questions, of course, in the exam, it will not be written Moore here, so you know. You have to tell if this is Moore or Mealy. Okay, how do you know? You look at the expression of the output. Does it have input in it? Do you have here the input? No. So this tells me it is Moore. Yes, guys, any questions? How do you tell this is Mealy now? Ray, can you answer? How do you tell this is Mealy?
اوكي this is mealy لانه عم بيتاثر بالانبوت لما طلعنا يعني ب S3 كان الانبوت 1 حطينا سوري كان state 1 حطينا له input 1 صار 1.
Hmm. So first thing you should notice, like you said, by looking here, if x is 0, I get this output. If x is 1, I get this output. So you are right. Output is changing according to x. This is your first remark. I agree. Now look at the expression and tell me why is this Mealy. What do you think? Yes, guys? Anyone?
لانه البي تي بلس 1 اعطتنا x a بلس b
لا
bar.
Look at the output.
X هي input.
Yes, it has x in it. X is the
X
input.
هي input so
Yes. So we say that O is a function of input, so this is Mealy. Clear the difference? Okay. So now look at this figure, please. This is the, how many flip-flops do you have here?
2.
Two flip-flops,
Two.
A and B. So you need to find the expression of A plus, of B plus, and of O. So you have to find these expressions. Can you tell me, please, what is A? A plus, what's the equation of A plus? Of course, this is A, and this is A bar, and this is B, and this is B bar. Yes, please. What is this? I want the equation of this.
A bar and B or X. لا and X. لا أول شيء A bar or A
Why
bar
A
or
bar?
B
Why
and
A
X.
bar, Joe? It is A.
إيه بالغلط شاتها A bar.
So A, B, it's an OR, right?
Yes.
Right? What
Yes.
how about B plus?
A bar.
So you have B, B bar, yes.
Or
A
A.
bar. table.
right? How about O?
A and X.
X.
Clear? Now look at this example, please, and tell me how many flip-flops do you have?
One.
Exactly. How many inputs do you have?
Two.
X and Y, right? How many outputs do you have?
One.
So
One.
if you have only one flip-flop, this is going to give you two states, state 0 and state 1. By looking at the output, output is always a 0 in the case of A, 0, always a 1 in the case of 1. Is this a Mealy or a Moore?
Dependent on the input.
Look at Z equal to A. Is it?
لا لا.
What are you saying? Is it dependent on? It's not. Okay, did you see that it
That's
is
Moore.
Moore?
A. We don't
Yes,
have.
we don't have X
Yes.
and Y in the equation, so this makes it Moore. Okay, clear? Okay, how can you read this expression now here? This. So this is A plus, and it is A X XOR Y XOR A. Okay? By looking at this, you will have to say that if A XOR X, it gives you a 1, XOR Y, if it is a 0, it will give you a 1. Okay? So let me go over the first. Yes, please. Who can tell me how did I get here a 0? Yes. Can you try, Elisa?
Can someone else try? So I see
Oh.
how.
Yes, of course. Who can? I will try the first, Elisa. Pay attention, you do the second, okay? So I have A XOR
Okay.
X XOR Y. So look, please. You have A, it's a 0. XOR X, it's a 0. XOR Y, also a 0. And do you remember when I do 0 XOR 0, it will give me, is it the same or different? 0, 0. They are the same, so they give me a
It's
0.
the same. So it will
And
give a 0.
yes, and 0 XOR Y is also 0, 0, so this will give me a 0. So this is why I got here a 0.
0.
Yes, Elisa, your turn.
Okay. So we have.
I am doing this now.
Yes. 0, 0, 1. Okay. X to Y is they're different, so it will give a 1. And 0 and 1 they're also different.
It will give you a 1.
Yes. Yes.
Okay.
Oh, okay. Here 1. Okay. Okay. I got it.
Okay. And now keep going with the second.
Okay.
Yes, Carmen, can you try?
So we have 0, 1, 0. No, 0, it's a 0. لا, it's a 1.
بس يكونوا
0.
different بالXOR it gives you a 1. Okay. بس يكونوا the same it gives you a 0. And so on. We fill all the table. And Z is equal to A. So we directly write it the same as A. So this is the same as A. Okay. And we filled the state table. Okay. Now we need to fill the state table. And this is the state diagram. Okay. The state diagram, you have a state and its output. So this is the first circle. You have the state and its output. And this is the next state and it is always 1. So this is the state and it is always output 1. Clear? And now you go over the input. If it is input 0, 0, 0, 1, 1, 0, 1, 1, you will remain in the same state. If you are in state 1 and you got 0, 0, or it will take you to this, okay? And if you are in 1 and you got 1, 0, it will take you to the 0, okay? So this is going to be the 4 cases, okay, that you have. Clear? Did you follow how we filled them? So if you are in state 1, you got a 0, 0, you remain in 1, okay? So here, you got a 0, 0, you remain in the same state. You got a 0, 1, it takes you to the second. You are in 1, 1, you got a 1, 0. It takes you to, so this is also 1, 0. You are in 1 and you got a 1, 1. You remain in 1, so this is also 1, 1. Clear? Did you understand how we filled the state diagram?
Yes.
So first of all, you will have to do you read the specification, you find how many flip-flops do you have, you write the equation, and then, of course, you do the optimize for the equation, so to make it as simple as possible using your K-maps, and then you draw the logic diagram and you do the verification, okay? We have now the sequence recognizer. The sequence recognizer, you have a list of sequence available, and you try, if you get the sequence, it will give you a 1. If you do not get the sequence, the output will be 0. So the sequence will keep going until you recognize the sequence of bits that you want, the output will be 1, or else it will remain 0. So throughout the finite state machine, what you will be drawing, the state diagram, the output is always 0 until you reach the end where the sequence is recognized, you get a 1. Okay? So I will start with a small example. We are doing now a sequence recognizer of 1, 1, 0, 0. So when do I actually get an output 1? If I have the first input 1, the output will be 0. The second 1, 1, the output will be 0. 1, 1, 0, the output will be 0. 1, 1, 0, 1, recognize, the output will be 1. Okay, so every time you recognize one bit, the output will remain 0 until you get the 4 bits recognized. It will give you a 1. So check now, please. I am in state A and I got a 1. Correct. You go to state B. If it is not 1, you remain in the same state. Okay? So you are in state B, you got a 1. It takes you to C. But the output is still 0 because I did not recognize the whole sequence. If I am in C and I got a 0, perfect. It takes you to D and the output is still 1. Now that I got a 1 after the D, now the output will become a 1 because the sequence fully is recognized. I got 1, 1, 0, 1. Now once the 4 bits are recognized, I get the 1. You need to know that it is a sequence, part of it. It does not have to be, look here. I have a 1101. Then again, I get 1101. So I have now 2 sequence recognized. You see? You see, this is the first, and then this is the second. Okay? So we start with this. Clearly, the final one in the recognized sequence is a subsequence. So it could start another sequence for you. Yani check this. 1101. You got an output 1. Very good. Now again, 1101. So this is going to be your first sequence. Will be your second sequence. You got that? Okay, so this is how you go more than once. We call it subsequence. Okay? So when you are in the last sequence and you got a 1, it will take you back to state 2, where you have the 1 recognized, and then you continue to find the second subsequence. Okay? So the subsequence 1 has occurred in this one. The subsequence 1, 1 has occurred. Here the subsequence 1, 1, 0 has occurred. Of course here none. We didn't have anything in the first. After you got 1, 1, 0 and now get a 1, it will take you back to state B. Why? Because now the subsequence 1 is occurred and I can continue. And you write here on the arc1 because I reached my output. I have 1, 1, 0, 1. So the last one was recognized in your sequence, so the output should be 1. Okay, so notice here, please. This is the nothing was recognized. Here I have a 1 bit recognized. Here I have 1, 1. Here I have 1, 1, 0. And it takes me back to B. Why did I go back to B? Because I have actually 1, 1, 0, and I got a 1. Okay, so this one could be used in my another part sequence. So this is why I go to B. I don't go to A where none were recognized. Okay?